Hello and welcome. This is Rashid Khan and you're watching my YouTube channel. In this video, we'll go through some exam questions on topic called energy. While I go through these questions with you, I would like you to pay attention to the annotation that I will do on questions, because this annotation will allow me to extract the relevant information that I need to consider while I'm answering these questions. First question talks about non-renewable sources of energy. So I have to recall what do we mean by word non-renewable. So non-renewable are the ones which will run out one day. So if you look at it, out of these, there are four options, but there is only one that will run out, and that is natural gas. So my answer to this question will be B. Next question talks about which statement describes conservation of energy in a closed system. So conservation of energy, we have learnt about this concept, and this means energy input will always be equal to energy output, provided no energy is lost. Here are four options available to us. The first one here talks about, again, when there are energy transfers, the total energy reduces. Now this is something that's wrong. It says the second part, again, the same way, when there are energy transfers, the total energy does not change, and that's something that relates back to this. So I can say my answer will be B. I don't even have to look at the next two options. Let's quickly move on to the third example. On the third question says, before a car brakes, it has kinetic energy. The energy decreases as it brakes. State what happens to kinetic energy during braking. So there it is, car, and it has KE. Then when you apply brake, the car will come to, either it will slow down or it will stop. In any case, whether you consider it being slowing down or coming to a stop, there will be transfer of energy taking place. So the energy that car has will reduce. So where will the energy go? We did discuss about it. The energy will be transferred to the surroundings. Let us consider question number 4. Now this time they've given us a kettle and it is heating water. They're telling us that this kettle has efficiency of 91%. So I've circled this number and I've written efficiency on top. Then it tells us that this much energy is transferred to the water in 200 seconds. So I can pick up this value and say this is my useful energy transfer, because this is the amount of energy that has gone to water. Now it says calculate the total amount of energy supplied to the kettle in 200 seconds. So we do not know the value of input. They've given you the value of time, but that is not useful in this question. Why? Because we are only interested in energy in this case. Now they've given you the equation here. Like I said before, there are three variables: efficiency, useful, and total. They'll give you any two and they'll ask you to find the missing one. In this case, we know the value of efficiency, we know the value of useful energy, and we don't know the value of total energy. So what we need to do now in this case is we'll plug the values in. But before I plug in the values, because this time this is a ratio, and when you have a ratio, then efficiency will be between 0 and 1. So we can't use a value of 91. We'll have to change it. So it will become 91 over 100 equals, what's the value of useful given to us? 3.3 times 10 to the power of 5 divided by total is not known. I can call it x. Now to solve this equation, what you can do is you can cross multiply. Okay, so 91 will multiply with x, it will become 91x. If you multiply them two together, you will end up with 3.3 times 10 to the power of 2. Make sure you put it in your calculator. Now to find the value of x, you will divide both sides by 91. This side 91s will cancel and you'll be left with a value of x, and that will be in joules. Let's have a look at the next question. Here it says a student lifts a toy car from a bench and places the toy car at the top. So it's going from location 1 to location 2. As shown in figure 2, describe an energy transfer. So they're only interested in one energy transfer that occurs when the student lifts the toy car from the bench and places the toy car at the top of the slope. So you have to remember, the car won't get picked up automatically, right? Someone will have to come and pick it up from the table. In this case, it is the student, right? So I can say the student will have a chemical store of energy. So it will be chemical energy in student will change into KE of car. Then this KE will eventually change into GPE. So you just have to pick one of them two. You can say this or you can say that, right? They both get you the mark required for this. Next question talks about a graph. So like we said, there will be two types of questions given to you in exam. There will be describe questions for graphs, and at the same time there could be calculation based questions. Now this question is about describe. So it says describe how the thermal conductivity. Where is thermal conductivity? If I go back to my graph, the thermal conductivity is on y-axis, right? This is my y of expanded polystyrene changes with the density of expanded polystyrene. So where is density? I can see density is on x-axis, so I can say this. So if you remember and recall, when it comes to describing graph questions, we looked at two things that you have to say because it's a two marker. So you'll say first, as x increases, what happens to y? I can't use x and y. I will have to use the variables given in the question. So I'll use here as density increases. What happens to the conductivity? Conductivity decreases. Second, I'll say again same thing. As density increases, what happens to the, remember, change in y over change in x, which is our gradient. Now this is a curve, so in this case the curve means the gradient is changing. For straight line, you have to remember here the gradient has a zero value, it is positive and it is negative. We don't have to worry about whether the gradient is positive or negative in this case. We only have to tell them whether the value is increasing or decreasing. So what I can do is I can put my pen on this curve and I can make it move. So if you look at it, it starts off with this. So it has a value, which is, although it is negative, but it has a value. And then eventually it approaches a value of 0. So I can say as density increases, then conductivity over density. But you have to say change, right? Because it's change in that, it will decrease, right? And that will get you the second mark as well. Let's move on to the next question. On this question, it says the student uses apparatus in figure 3 to find which two materials, sand or sawdust, is better insulator. If you guys remember, I did discuss about it. This will be to reduce heat losses, right? That's what we have to remember. Here it says student also has a kettle to boil water, a thermometer and a stop clock. So they've got stop clock, thermometer, and they've got kettle, plus they've got these equipments available. So this is my insulator, sand, number 1. Sawdust is also insulator. They want to determine which one is better from them. Now we can't cover this copper can on its own with sand because the sand will not stick to it. Here it says, draw a labeled diagram to show how the student should set up the equipment to investigate which material is the better insulator. So better insulator. So what they'll do is they will take the big can and then they will place the small can, right? Now I can say here I will fill, this will be my insulator here. And then I can fill this can with, let's say, 100 centimeter cube of boiling water. Now because I need to determine, I have to reduce the heat losses. So this means I will have to figure out how the temperature will change over time. So I'll have to include thermometer. Okay, thermometer, and then I will need a stopwatch. This is my stop clock, right? So I'll record. In this case, you will record temperature. Let's say after 5 minutes, right? First, you will do this experiment using sand, and then you will replace sand with sawdust. In both cases, you'll record the temperature after 5 minutes. The case which gives you bigger value of temperature will indicate that material is a good insulator because it will be better at keeping the water warm. Now next part says give 3 factors that student must control in this investigation. Must control means should not change. So here we'll say the volume of water used. So in both cases, when you're using sand and the next time when you use sawdust, you must use the same volume of water. Here I've used 100 centimeter cube, right? Number 2, the starting temperature of water. It has to be same for both, otherwise it's not going to be a fair test. Third bit, we can say the amount of insulator used. Because if you use different amount of insulators, again, it will not be a fair test. And then the number 4, we can say the time used for measuring temperature. Okay, and that will get you the 4th mark as well if it is a 4-mark question. These are the 4 things that you will have to keep the same when you perform this experiment. Let us have a look at the next question. This question is very, very important because it is about conservation of energy, but this time it is not in terms of qualitative responses. This time it is about quantitative responses. So here it says electricity can be generated using a water turbine. Water gains Ke by falling from the top of the dam. So I can say this is the situation that applies. So here the water will have GPE, here the water will have Ke. It says calculate the minimum height which that 7 kilogram of water must fall to gain 1300 joules of kinetic energy. So I can say this is the value of mass given to me and this is the value of Ke. So in this case you need to remember GPE will be same as Ke. Now the question talks about minimum height. Height does not appear in equation for Ke, it will appear in the equation for gravitational potential energy. So we'll write down m times g times h equals, what's the value of Ke? It is 1300. Now because it is about our planet, the value of g on Earth is always 10 Newton per kilogram. You have to memorize that, right? Occasionally it may be given, but in majority of the questions it will not be provided and you'll have to remember that, right? So I can say the mass given to me in question is 7. This is the value that I must know. I can put that down as 10 times by h equals 1300. You can multiply them two together, it will change to 70h equals 1300. You divide both sides by 70 and you will end up with a value of height which will be in meters. On the second part it says as water enters the turbine at the bottom of the dam, the kinetic energy of 8 kilogram of moving water is 1100 joules. So this is the value of Ke and this is the value of m. So the situation is like this now. Here it was GPE, here it is Ke. Now then the water enters into turbine here. So when the water enters into turbine, they are now asking us to calculate the speed which we do not know. Okay, so again, what is the equation that relates mv and Ke? There's one that is Ke equals half times m times v squared. I told you earlier as well, a lot of people will miss this square and they will lose marks on this question. So I can say Ke, I can replace it with the value 1100 equals half times 8 times v squared. I can multiply them two on my calculator. It will give me 1100 equals 4 times v squared. To remove 4 from the right side, I'll divide both sides by 4. This will cancel out, leaving me with 1100 over 4. V squared equals 1100 over 4. Now to get it off this square, I'll have to take square root on both sides. And if you do that, you'll end up with a value which will be meters per second. Very important question from your exam point of view. Next question says, explain why renewable sources provide an increasing fraction of electricity supply for many countries. So in other words, they're saying, why is it that in many countries more energy is being produced from renewable resources, right? So we can say this is because renewable sources are being used in greater amount. Okay, Now it's an explain question, so I have to give the reason for this. Why is it that they are using renewable energy in greater amount? This is because, okay, this is because they are cleaner. Okay, so they are more environmental friendly. This is the last question on this worksheet. Here it says shot put is an Olympic event. There's a heavy ball that is used in this event. Athletes throw this as far as possible. Now the scientists are analyzing the situation to help improve performance. Now in one throw they are telling you what is happening. The shot put continues to rise by another 1.3 meters. So this is the value of height because it goes up by this after it leaves the athlete's hand. The mass of the shot put is 7.2 kilogram. That's my mass. It says calculate the amount of GPE gained by the shot. So we do not know the value of GPE. It is not known. Okay, so what will I do again? Like I said to you, I need to pick up the equation for GPE. GPE equals M times G times H. The moment you see this equation, then you need to recall. If the question is about our planet, if the things are happening on our planet, then the value of G will still apply as 10 Newton per kilogram. We do know the value of M in this case, which is 7.26. The value of G is 10 and the value of height is 1.3. Now in your exam, this question might be 3 mark. If it is a 3 marker question, then this height may require unit conversion. If you multiply them 3 together, you will end up with a value of GPE and it will be in joules. Okay. With this question completed, we have done a couple of questions on this topic now. I hope you have found this video useful. I wish you all very good luck with your exam preparation. Thank you.